Hi, and welcome back to another episode with It's Dr. Dan. And today we're going to be looking at the pH scale. So, pH is all about the measure of acidity of hydrogen ions in an aqueous solution, meaning that whenever we have any type of solution that you might have around the household or in the chemistry lab, they have a pH to them, meaning they have so much acidity to them. So, this is all about the potential of hydrogen. So, how much hydrogen ions do we have within a solution? So for pH, this is a scale that is a very simple range. It goes from 0 to 14. It is a simple scale so that way we can easily be able to relate it to normal numbers that you can count on your hands and toes. So if we have a scale like this, the way that it generally works is it goes from 0 to 14, meaning that we have a range of how acidic something can be. So a pH of 7 is usually where we all want to start. That is where we have water. That is just a normal pH of 7, meaning this is neutral. So you can drink drinking water and it is generally safe for you to do. Now, as you go into the more acidic side, that is when the pH is going less than 7. So the lower that number, the more acidic something is, meaning the higher that hydrogen ion concentration is within a solution. So if you kind of change some of those things that you might kind of recognize is if you go around like a pH of 4, pH of 3, those are things like soda, juices that you commonly find at the supermarket. Those are very acidic. They're harsher on the stomach when you drink them. Other things that are a little harsher are things like coffee, for example, right? Coffee also has a very, very low pH. Some other examples that you might find in your general household are like lemon juice and vinegar, things that you commonly use in cooking, right? A lot of times these are acidic ingredients that we see in salad dressings that give us that sour taste. They help break down different ingredients and unlock a bunch of different flavors. Some other things that we also have is a really low pH, a pH of 1. That is your stomach acid, so gastric juices. So when you eat something, it travels through your body and eventually it comes down to the stomach, which will break down foods even more by causing all those bonds to break. Some other things that you might come across is battery acid, right? If you have to change your car battery out, in that there are different, very, very common things that you always see, right? pH of 5 and 6, bananas and milk, all your household chemicals. As we go in the other direction, this is increasing alkalinity, meaning that the base portion is getting stronger. Bases are always represented by hydroxide. So OH minus is dissociating off of a solution. So when we go in this direction, things like eggs, baking soda, milk of magnesia are also some common things that you find in a household. As you go farther down, more things that are cleaning products that you use to uh, to clean your home, like ammonia, maybe soap, bleach, drain cleaner. These are higher pHs because they are something that's going to break down a lot of those oils and fats and things like that. So this is what we're going to be looking into and trying to understand how this scale works as we go from a 0 to 14 and what different calculations might apply to you within your chemistry class or your introductory chemistry or your general chemistry course. And I hope that this helps. Please feel free to like and subscribe and stay tuned for examples to come. Hi, and welcome back. So, with this one, what we're going to look at is first, let's diagnose what is an acid, what is a base. When it comes to pH and pOH, we can go and look at a variety of different acids and bases that vary in strength. For today's little mini lecture, we're going to mainly be looking at strong acids and bases. What does that mean? Well, if we want to look at the basic example of an acid, let's say if I have something like HCl, which is one of our common strong acids, if that is to dissociate in water, what exactly does that make when it breaks down? We want to look at what ions make this ionic compound up. And one of those things that it makes up is H plus and Cl minus, which are our two halves of the compound that are here, right? So those are our two pieces. Now, why is that important to us? Well, this H plus portion is what you are going to be measuring using pH. So pH is where that comes from. Now, when it comes to a base, this is going to be a little bit different when we are looking at a base. So base is when let's say if we take something like NaOH. Now, the thing that makes these acids and bases is it's H and then OH. So OH is really where you see that base characteristic is coming from. So once again, when we put this in water, we're going to see that this is going to break down into its 2 ion compounds. So sodium is going to break off and hydroxide is going to break off as well. So we'll have Na plus and hydroxide. Now, when this is breaking off the OH minus, where we can measure pH, however, there's no hydrogens that are being generated. So what we're going to be talking about is a different type of pH. Instead, it's going to be pOH is what we're going to be talking about in a little bit ahead. So the first one though, pH. So in order to measure pH, we're going to be using the following formula, which is pH is equal to negative log of H plus. Now, when we are dealing with this, for a lot of chemistry students, you might not know how to use log function or you're not used to it. So let's talk about what exactly is a log. What does that represent? Well, a log is short for a logarithm, which is a function that you can find on your calculator. It should say LOG is the button that you were looking for, not LN. So keep that in mind. They are two different functions. So we're looking for a logarithmic function. And with this one, these are mathematical functions that tell how many times the base is multiplied by itself to reach the number that you have. So what exactly does that mean? So it's not the log as in a log that you find in the woods, but instead it is a mathematical function. So every log, generally you see that there is a little number next to it. With your calculator, it is automatically assumed that it is a log base 10, which is the normal log system. However, some calculators, you can actually put what type of log you want. So pay attention if you see a little tiny box next to the log function, that's telling you need to input a number there to put 10 for these calculations. So if I have, let's say, 1,000 here, well, what it's asking is how many times would I have to multiply this base to fit into 1,000? So if you think of 1,000, right, if I do 10 times 10 times 10, the 10 times 10 is 100, 100 times 10 is 1,000, you had to do that 3 times. So that tells you that your log is 10 your log is 3 in this example. So, and this is really where pH is coming from. So it's a 10 based scale, meaning that the concentrations are, being that this is a negative value up in our formula up here, these are going to be very, very tiny numbers that we're going to be dealing with. So the concentration is small and it has so much capability here for such a small number. And this is where we're going to go into our next and upcoming example. Hi, and here we go. Let's do this example. So if we have the following question, a student prepares a 2.1 times 10 to the negative 4 molar solution of HCl. So with this type of formula, when we are using the pH equation, this is always going to be relating directly to the negative log of the concentration of H plus. Meaning when we have concentration, those square brackets are always telling you about molarity. So we're going to always be in moles over liters when we are looking at those units for either H plus or OH minus. So being that HCl is a strong acid, it's going to completely dissociate into H plus. So those concentrations are going to be equal to each other. So the concentration of HCl is going to be equal to the concentration of H plus, and this is for strong acids. So keep that in mind. That's something, there's 6 strong acids. That'll be its own video, and that is one thing to remember. So when we are doing this, what we're going to do is we'll take the pH. It'll be the negative log of 2.1 times 10 to the negative 4 molar, and that's going to be in the parentheses here. Now, when you put that into your calculator, what you're going to be getting is 3.677 is your number. So that's telling you how many times negative or 10 is fitting into this calculation when we are trying to calculate this. Now, how do we do sig figs? Well, sig figs is always something we got to make sure we are accurate about in the lab. So when it comes to the amount of sig figs, it's equal to the number of decimal places in your pH value. So, and also what you had in your original number. So if we had in the original calculation, we had 2 sig figs. So what that means is that we also are going to have 2 sig figs in our decimal places in our pH value. So when we convert this, this is going to become 3.68 is going to be our final one. So it's all about the decimal places when it comes to significant figures for these examples. So if I continue this problem and I ask you, all right, what is the H plus concentration? And then you might say like, well, wait a minute. Didn't you say earlier that HCl is equal to H plus? And you are right. So that what that means is that number is 2.1 times 10 to the negative 4 molar is my concentration. However, there's a formula to go back in order to go from pH to your original concentration. So that formula is a little bit different. So what we are going to be doing here is if we have our pH formula, we have to take an inverse log to go to concentration. So an inverse log is simply the following thing. So if I have my hydrogen plus concentration, that's going to be equal to the 10 to the power of negative pH. And that is our other equation that we are going to use in order to find the concentration. So if we use that here, what we can pretty much do is if I do the same calculation, let's say you didn't know that it was a strong acid and you didn't know how to do it, then we would go 10 to the negative 3.68, and that will give us an answer of 2.1 times 10 to the negative 4 molar for our concentration of H plus for this problem. So you can go back and forth between those two values. And that's how you do pH and find the concentration of H plus. So if pH tells you the strength of acidity, then pOH must tell you the strength of alkalinity, meaning that we can do the same calculations for pOH. So if I have a base, we can figure out how strong that base is instead of it being represented by an acid. Remember, these are two different species. They're related to each other, being they can neutralize one another, but it all depends on what example are you given. Are you given an acid or are you given a base? Because that's what your calculation is going to be referencing. So if I have the following problem that says the pOH of ammonium hydroxide is 8.6, calculate the molarity of OH minus ions. So this is the same formulas. pOH is equal to the negative log of hydroxide concentration, or if you want to take the inverse to find the concentration, hydroxide is equal to 10 to the negative pOH. So being that we want to find concentration, we're going to use the formula on the right-hand side, which is in yellow. So with that, what we are going to do is we are going to take our formula. We are going to be solving for our hydroxide concentration. So we'll take that OH minus, and that's going to be equal to 10 to the negative pOH. So 10 to the negative 8.6. And what that's going to tell us is the concentration of hydroxide in solution, which is going to be 2.5 times 10 to the negative 9 molar of hydroxide that is within our solution. So, and that is how we would go about solving for molarity. Now, when it comes to both pH and pOH, there's a relationship between them. They are bound together. So if I know my pOH, I can also calculate what my pH is. So pH and pOH, if you add them together, it's always going to equal 14 at 25 degrees C. So at standard temperatures. So being that if we know our our value, what we can simply do is we can rearrange this formula to solve for, let's say, pH, and find out exactly what the pH and how much hydrogen ion there is in the solution as well, being that all these are in a solution of water. So being that this problem, I had 14 and then I had my pOH was 8.6, we can quickly find what our concentration is of our pH, which in this case, we would have a pH of 5.4 would be our pH, which tells you that even though this is a basic solution, it is a really weak base. It's not that strong of a base or not that high of a concentration that we have. It is a very low concentration. So being that this solution is slightly more acidic than basic. In summary, what does all this tell us? Let's look at how all the formulas work. So originally, if we started from a concentration of H+, we can convert that to pH. In order to convert that, we needed to use the negative log of H+ in order to convert that. If you wanted to go backwards, we can do that as well, where we take the inverse of a log, so that would be 10 to the minus pH to go back. And let's make that a little bit bolder before we do that. So we can always go back here. If we needed to. Now, in order to connect pH and pOH, we can do that as well. So we can always have an equation between both of these. So if we want to go to pOH, that was simply pH plus the pOH is equal to 14. So you can bridge between those two values. Now, if we wanted to do our last one, let's say if we had hydroxide here, we can also bridge the gap between these as well. So if I want to go to hydroxide, we could once again take the 10 to the negative pOH to go over to hydroxide. Or if we wanted to convert back to pH, we could find the negative log of OH minus to convert back. So it's a cycle. So how do we connect the last one? We didn't talk about that, but there's a formula for that as well. So if we wanted to link them, this has to do with the properties of water, which is another formula for another video and another time. But just to show you what it is Kw is equal to the concentration of H plus times the concentration of OH minus. So in Kw is equal to 10 to the minus 14. So it's an equilibrium constant. So in our future videos on equilibrium, and especially on acid-base equilibrium, we'll bring that into the fold. So these are how you can convert going between acids and bases. So that way, if you need to do any of these different calculations, you can use these in your chemistry class to hopefully be able to succeed and get an A and do really well. Thank you so much for hanging out and watching this video. I hope that it helped. And please like and subscribe for more to come. And please refer these to as many people as possible that need help with chemistry. I'm here for you, and this has been Dr. Dan, and I hope to see you again in the future. Bye now.